One of the first things that tends to freak people out about learning electronics is this. A schematic. Understandably, this can look pretty intimidating to those unfamiliar. So let's start by clarifying a few things. A schematic is a simplified representation of an electronic circuit designed to be easily read and understood. With that being said, a schematic is not a physical map of a circuit board. We use it as a guide when constructing or designing a circuit board, but we usually end up rearranging components in order to accommodate physical constraints like board size and component size.
Each symbol in a schematic represents a physical component, and each line represents a wire or conductive trace that connects the components together. Because a lot of different connections need to be shown, you'll often see two lines cross one another, but this doesn't mean they're connected. If they were, a dot would be used to illustrate the junction between them. So yeah, no dot, no connection.
That covers what a schematic is and what all those lines all over the place are. But what about all these component symbols, eh? What's up with them? Well, there's several you're most likely to run into.
A resistor's symbol usually consists of a single zigzagging line. It's also sometimes represented as a simple rectangle with a terminal lead at either end. That zigzagging shape actually hints at what a resistor does. Instead of allowing electrical current to flow through smoothly, like it does through a wire, a resistor restricts the flow of current, forcing it to follow a limited path of conductive material. Because a potentiometer is a variable resistor, it uses the same symbol with the addition of a third terminal to represent the pot's wiper. A capacitor symbol also describes how it works. The two T-shapes used in the symbol represent the capacitor's internal conductive plates, which are separated from one another. And it looks a whole lot like a simple parallel plate capacitor. Polarized capacitors use a plus sign to indicate their positive side and a curved line to indicate the negative. The symbol for a diode can be interpreted as an arrow pointing towards the component's negative or cathode lead. I like to think of it as an arrow bumping into a wall. Electrons can move from the negative lead to the positive lead, but they're prevented from moving in reverse. This symbol also resembles the basic structure of a point contact diode, which uses a metal point held against a semiconductor chip. If we add two small arrows to the diode symbol, like so, we have the symbol for the ever-popular light-emitting diode. Integrated circuits are often symbolized as a basic rectangle, with a line used to represent each pin, and abbreviations to specify pin functions. The layout of these pins can differ quite a bit from their arrangement on the actual body of the IC. So it's important to pay attention to each pin's number label in order to determine its corresponding pin on the IC's physical layout. ICs that perform very common functions, such as operational amplifiers, have their own dedicated symbol. And if a chip includes multiple instances of this function, each one is usually treated as a visually separate element.
So once you've picked up a few basics, schematics really are pretty easy to understand. And they enable you to make some very awesome stuff. Plus, I just think they look cool. Huh?